Are you already a Flux users? Or you need to start from scratch? Or okay, great. And great. So you already have many a Flux experience. Third question, and the last one. What is your background? I mean, what kind of engineer you are? Electrical or mechanical, or not an engineer, just a technician? Okay. Okay. Great. Thank you for the feedback. It is very important for us to collect some data, feedback, and to adapt then the contents. Okay, so let's start with the training, looking at the topics. Today, we will start by learning what SimLab is and how to use it to set up a magnetostatic example. As you can see here, today we have the getting started. So the idea here is to start from zero to hero. So you will learn how to use SimLab for electromagnetic application in these 3 sessions. For any question, don't hesitate to write in the chat. Okay, so we will start with the getting started, means we are going to see what is SimLab, why use Altair SimLab, and just at the end some takeaways that you can use if you start to work with SimLab. And then we are going to see a basic example, is a singleton coil, is a magnetostatic, it will be a magnetostatic solution. We are going to have an overview of the post-processing tools. And also we are going to see how to set up a DOE in SimLab. So just in the introduction, you can see the application, but yeah, we can go step by step. So welcome to Altair SimLab Electromagnetic. The idea of this course is to guide you through the GUI and the basic functionalities of Altair SimLab Electromagnetic. And the electromagnetic solution as Altair Flux solver in behind, the well-known finite element tool to solve the Maxwell's equation at low frequency. So practically what we have is the GUI from SimLab and the solver from Flux. This means, this creates the SimLab electromagnetic. During this course, you will discover SimLab for electromagnetic analysis, and you will learn how to choose the electromagnetic domain and the application depending on the geometry of your device, how to create and parameterize 2D geometries, and also to create basic 3D geometries. We are going to do a demo depending on the timing, today or tomorrow, on how to create the singleton coil with the 3D and how to mesh it. How to import a CAD file. SimLab is working in Parasolid native, but as a native motor. But yeah, you can use every kind of geometries, more or less, you have. How to create mesh controls and how to generate the mesh. So this is the power of SimLab to create mesh, especially in 3D complex geometry, because it's very flexible. And with the mesh control, we can have a local adjustment on the mesh, and we are going to learn how to use them. How to set up a 2D static and transient electromagnetic analysis. But today, tomorrow we are going to see also the magnetic assay application, and how to set up a linear and rotational movements. Especially one of the key will be understand of the today exercise is the understanding of the post-processing tools, and also how to create a DOE solution based within SimLab to very physical parameter. Just physical parameter, we have some limitation in the 2024.1 version, but 2025 version is coming out. So please, you can follow the training, and then you will be able to generate parameter for today and tomorrow. You can use them in your models. Okay, so just a brief overview of the Flux solver. This is important just because, as I said, the Flux solver is in behind. So the rules are from Flux mainly, right, for your model. So as I said, Flux is a finite element tool for low frequency electromagnetic, and is capable of simulating both 2D and 3D topologies. We also have the SKU, mainly dedicated to electrical machine. Flux includes circuits and kinematic coupling to consider different kinds of electric supply and motion, rotating, translating, or pivoting into the simulation. And we are going to see, in fact, also the movement in this training. This is important because the mechanical equations are coupled with the electrical one and the graphical view. So the model is solved under all the constraints you have. So Flux is able also to solve the magnetic and the dielectric field with linear and nonlinear materials. The frequency limit depends on the model dimension. I spoke about low frequency, but the limit, for sure, it depends on several things. Model dimension, the length of the wave, for example, and we can predict the behavior of all existing electromechanical device, magnetic heaters, magnetic sensor, and all the electrostatic application. So we have no limitation with Flux and so with SimLab in solving this kind of devices. Yeah. So why use Altair SimLab? Yes, as you can see, SimLab is a single interface for multi-physics problems. So it contains the Flux solver, but not only. We have the link to Flux motor. We can create the part starting from SimLab. The parametric or non-parametric part. For the moment in 2024.1, only the inner magnet part is available, but we are including other type of parts. We also have inside the SimLab, we also have the structural solver, the flow solver. So we have OptiStruct and AcuSolve for the people that already know our tools. But we can also perform some analysis for the thermal, the fatigue. We have the possibility to perform DOE with multi-parametric data. We have the link to HyperStudy to create DOE and optimization in a dedicated interface. So we can do the same, similar things. I mean, a DOE, we can set up a DOE in Altair SimLab, but HyperStudy is the tool for this. So you have more freedom than to post-processing the data and so on. SimLab can be automatized, but we are going to see it later. As I said, is a single interface to solve multi-physics problem. So we have multi-physics application, and the plus of this is that all the solution in the same model. So with SimLab, you don't need to extract data and to put it in another software, in another tool, but you can just solve the model, take the results, and create a link between two solutions, for example, to solve multi-physics problem. And this is a very big plus for this tool. In fact, it supports a variety of physical solutions, includes electromagnetic, structural, acoustic also, and CFD flow. And it will invoke the following solvers, as you can see, Flux, OptiStrat, AcuSolve. But the user can see just SimLab. Okay, so all the things are simplified in order to speed up also the modelization. Okay, this is the SimLab electromagnetic architecture. We have the magnetic solution, as you can see, with all the domains, and the electric solution. For the moment, we have the electric conduction and the electrostatic, as you can see, but we are completing in a very fast way all the domains. And for the magnetic, we are quite full. So there is also the hybrid method, what we call PE and SCAC solution, that comes from the old Flux PEC, but with a lot of improvement. So if you have any doubts, don't hesitate to ask question. Yeah, these are the application. So what we call solution in SimLab, dedicated to the flux solver. We can see the electromagnetic and the magnetic application that will be the solutions that we are going to cover in this training. Then we have the electrostatic, the electric conduction, the parasitic extraction, and the acid supply. Also, I underlined also the coupled solution because it's quite important when you want to consider thermal and electromagnetic and at the same time. And we have a training that show this type of workflow. And we have the e-motor solution. E-motor solution contains the e-motor acoustic solution that is also in this training that I'm going to present you in a few seconds, and the flux motor solution that allows to create the part and the reduced motor. So these are mainly the domains. So 2D, 3D, and the SKU that is coming soon in SimLab. And just a few words on the solution that we have. So we have the magnetostatic solution is the most simple one. It considers stationary currents. And we can consider magnets in the domain. The typical application could be the contactor. We have done the transient magnetic with variable currents, so no limits in the variation in time. We have variable states, and we can consider also a steady state, no limits, as I said. And also here the magnets can be considered. A typical example could be an EPM motor, and we can perform transient analysis, for example, to understand the torque that it produced. And as last, we have the steady state AC magnetic, what we call in SimLab magnetic AC, that considers sinusoidal, only sinusoidal currents. So the analysis is made in steady state, and magnets are forbidden. Please remember. So since magnet is mainly a static source, in the steady state AC magnetic, you can consider them. And this is a typical application, the transformer. It could be a simple transformer, a very complex transformer with surfaces, as the case, where we want to better understand induced current, for example, or no limitation. So this is the typical magnetic application for SimLab electromagnetic. We have, as we already seen, motors, but we also have wireless charging, sensors, any kind of sensor, actuators, transformers, cables. Also, EMC can be analyzed with SimLab and shielding. We have a way to represent some surface with electrical and magnetic properties without represent very thin surface, without represent the real thin of them, just to simplify the model. And this is why, because SimLab electromagnetic has to be the hair around of the device. So the quality mesh is important, but especially in 3D, we have to be careful. Okay, Flux has similar domains. Is SimLab just a question? Also going to be used to use PSIM or other tools, and they want to consider all the system in one tool with a simplified modelization. So let's have a look at the SimLab electromagnetic learning path. So no prerequisites for this training. You can just start to use SimLab electromagnetic here with this training and SimLab in general. But since each solver that is in SimLab has different rules, different mesh rules, different um, description, different tools. So this training is just for SimLab AM. If you want to learn more about SimLab for mechanics or for other physics, don't hesitate to follow and to attend one of our training that are available in the on our site. If you have some interest, please don't hesitate to write me in the chat. I can forward to you the link to register to the other training. Okay, so after this training, we already have the SimLab multiphysics analysis of electric motor training. And what we have in this training is a multiphysics analysis dedicated to motor. So this means that in this training, you can attend and is available. You can create a parametric geometry of a motor. You can see a surface permanent magnet motor section. So the model is in 2D. We will solve the 2D model, and we are going and we used the couple solution. This is not up to date probably, but to pass the loads to the other to the thermal solver. But we also have the possibility to pass the load mapping in order to perform MVH analysis and acoustic at the end. So we have different solvers that acts on this training, and you will see electromagnetic, CFD, MVH, and acoustic solutions in just in one training. So this is a pretty interest in my opinion, and you can see the full workflow dedicated to a motor. Okay, so some takeaways before start. The first one is how to set the working environment. You have in the view the possibility to enable the model browser, for example. Model browser is very important, and yeah, from here we are going to select all the entities that are in the model. Okay, so it's very important to have the model browser active. Then we have the output window. Active it, but you can enable it if you want. What I suggest then is the selection list. The selection list is quite important because you can take the feedback from the selection, and so you can know in every moment what you are doing. Okay, and then we have the graphical view for sure and the control panel. But these type of things we can see them later. Another important thing is how to set the number of cores. So is an option, and yeah, we want to just to give you some slides that you can take if you have some doubts. So preferences general, you can find it. Verify the scratch directory. Also, this is important because sometimes you start to work and then where is my folder, where is my model. No problem. There is the Scratch directory that you set during the installation, so you can change it if you want. But we will see how to set up the working directory later for sure. About the electromagnetic workflow, okay, so in this case, the electromagnetic workflow should disappear in 2025. So we are not going to use it in this training, but yeah, you can enable it, and this means that a new ribbon will appear in your GUI, in your SimLab tool, and in there you will find all the electromagnetic tools that you can use to set up the model. As I said, the same tools are available in other ribbons, so you can decide to use it or not. Yes, just some tip. If you are in trouble to get help, you can press F1. There is the Control F or the search window to the top right of the screen. If you don't know where is a tool, just type the name of the tool and click on the line. This is very, very useful. We have also the Learning Center that I want to show you quickly. The Learning Center is very, very useful because it contains a lot of examples. You have the video link, but also you can download the model. I'm opening SimLab in the meantime. And yeah, so the examples are divided depending on the solutions and on the physics. You have the access to the Learning Center, just going into a file, help Learning Center. Then we have yeah, just some words on the geometry formats and CAD integration. We can have the possibility to integrate native CAD format, but normally SimLab works with Parasolid, is Parasolid based. Okay, so this means that we are going to see how SimLab will use the Parasolid geometry. But you can import any kind of geometry you have, mainly. So STL, SolidWorks, Native CATIA, and many others. The same for the export. You have general step file, and also sat file and so on, Parasolid. And for the results export, we have the CSV, so Excel formats, test, and the XML. It's also possible to script, to use the script with SimLab. We have a very well done training. Is a SimLab automation the name, and you can, if you are interested in scripting, you can just attend the training to become a hero. So this is the standard workflow we are going to follow. So create solution is normally the first step that you have to do in SimLab. Then we can create the geometry. We have different ways to do it. We can import the geometry and do the geometry simplification, or just create the parameters and create the sketch inside SimLab. About the meshing, all the geometries can be meshed. Then we have the physical setup, so material assignment, create the circuit, the periodicity, and the infinite box is in Flux. And at the end, we have the solve and the post-processing. So for the post-processing, we are going to see today an overview. We are going to have an overview of the post-processing tools, and we are going to see plots and animation. The last, I think, is the last takeaway. No, it is not the last one, but we are going to finish the first part, the getting started. So it's very important when you open SimLab for the first time, you will have this window, and this is very important for the users that are that want to use electromagnetic solution, because normally Flux works with the millimeters, and so by default the units are set to mmks, and you can check it here at the bottom right of the screen. Okay, in any case, you can change it, but by default, this is set. And the last, yeah, about the meshing, I put here just some a standard electromagnetic meshing approach that you can use. SimLab works, as I said, with mesh controls that are available for any kind of things. So we can create mesh control on the body, on the face, on the edge. Mesh controls are local controls that we can use to improve the quality of the mesh on some parts, right? Then we have the surface mesh and the tetra mesh. So surface mesh is mainly dedicated to the surface, can be used in 2D but also in 3D. So the process for the 3D meshing could be create mesh control, do the surface mesh, and then create the 3D mesh. The surface mesh offer different possibilities. Mainly tetrahedral elements are used. And the most important things to remember is that the create matching mesh is suggested, is an option that is very, very suggested, because SimLab then is able to, for example, create conformal mesh between solids. I'm going to explain better the reason behind, but later. But just just a takeaway for you to remember about meshing in SimLab. Okay. So the very last one is how to export the model for Flux. This is a very important thing, because in any for any reason you want to skip to Flux, especially for already Flux users, so for people that are used to use Flux. So you can click on the solution. In this case, is magnetostatic, but it doesn't matter. So right click on the solution, and you have export and open in Flux. Right, so Flux will start, and the model will shown in the on your screen. Okay, so we hand the getting started. Today, as I said, we have a basic example, the single turn coil, the magnetostatic solution. We will set the magnetostatic solution. We are going to see the post-processing tools, and we will perform a DOE. So before start, I want to be sure that you downloaded the material. So please ask me. I put the link in the chat to download the material. If you, okay, great. Let me put again it, so all the people can download it. And we need, okay. Okay, I put the link for the material in the chat again, so please download it. So before start the exercise, let me take just 30 seconds. Okay. Now I'm going to take the basic example exercise. Just a moment. Okay, so okay. So we are used to just to reply a question. We are used to deliver the training material day by day. So if you are not, if you cannot attend the next training, please send me a message. I will share the material with you. Um, okay, so this is the basic model we are going to create. No starting files are required. And we are going to set up the model. So starting a new project, and we are going to see the basic operation or the very basic operation that we have to do in SimLab to create this model. So starting from a new project, we will create a solution. We will learn how to set the working folder. We will see how to create a sketch and realize it. We are going to do the surface meshing. And then we will have an overview of the post-processing tools. As I said, the example is very simple, is a single turn coil. As you can see, an image of the results in terms of magnetic induction. And we are going to set up a DOE at the end. So a design of experiment at the end within SimLab, just to show you the workflow to use in case. Okay, before start, just a few words on the problem description. We have the study of the magnetic field and flux density developed by a single turn coil. You can see an image here. We will compute the flux density at the selected point along the x and the y axis. We have some data here, the coil radius, the wire radius, and the current density. The domain will be axisymmetric, and we are going to see the reason. And the regions will be just two, so the wire and the around. That means the hair. Okay, so the goals of this exercise is discover the environment, discover how to create a sketch, understand the axisymmetric domain, discover the workflow to set a magnetostatic problem, and the basic meshing tools, all the post-processing tools that we can use in this example, and how to set up a DOE to vary a physical parameter. So an easy real problem has an introduction. So I think we can start opening SimLab as I already did. So let me take SimLab. Okay, I hope you are ready to start. Okay, once you open SimLab, you can see a database. So just double click on the icon that you have on the desktop. And you can see that the new database, the new SimLab database, the name is normally database one, will be created automatically. So this is the name of the model, right? Okay, so to create an electromagnetic solution, just a moment. Ooh. Okay, so to create an electromagnetic solution, we can go to the solution, electromagnetic, magnetostatic, and then a new window will appear. As you can see, we are going to set an axisymmetric, a magnetostatic case with domain axisymmetric. So we can click on OK. The name is not important, magnetostatic can be fine. The flux is set by default. We can click on OK. And once it click, we have the alert of the MC axis workflow ribbon. As you can see here, it appeared. And this is an option, as I just explained. So you have to go to preferences to check and enable the workflow. But since it will disappear here, we have in the option enable electromagnetic workflow. So you can click on it or not. It doesn't matter. What I said is that we have the tools in the other ribbon, right? So, okay. So just a few words on the axisymmetric domain. So why we set the axisymmetric domain? Yes, the reason is that the singleton coil can be created with a revolution respect to the center axis, right? So, and the vector field on a plane with one side, let me show you, at the center line is equal for each rotation angle, you can see. So then the axisymmetric periodic boundary condition can be applied to speed up the computation. This is just a technique that we can use for a specific for specific geometries and physics to speed up the computation in order to save a lot of elements and so a lot of nodes, right? So the magnetic field is then computed based on the source phase that is half of the section. And this is more or less the principle. Just to explain the principle behind to the people that are not used to use Flux or this type of solver. So the new solution is available in the solution browser. We have the browsers here. You can activate it from the view. Okay, and we set a magnetostatic solution, right? So the first thing is to set the working folder. And how to do it? Right click on the solution folder, set to the selected folder, and we can set up our working folder. So you can navigate in your laptop, and for example, okay, create the folder. So this means that SimLab will save all the things in this folder, right? So first thing is to create the sketch. So how to do it from the sketch ribbon, you can click on new sketch, select, so click or select the yellow plane, and the view will change in the XY plane. You can also, yes, you have the view panel here if you are interested in it. So first thing, we need to create the wire. And to create the link for the wire, I read the question. And to create the wire, we can use the circle by center and point here tool. So clicking on it, you can just move the cursor and put a point along the x-axis, for example. When you position the cursor right, you can see here you have a reference of the position. So you can enlarge and create a point along the x-axis. Point should be positioned in 10, 0, but it doesn't matter. Don't worry, because we can change the position later. Okay. So second point, once you click, second point should be placed. You can place it anywhere. It doesn't matter. Along the x-axis is better. Okay, click, and then um, a new window with the radius will appear. Sorry, with the diameter will appear, and we want to have 1. Okay, so we can just type 1 and press enter to set. As you can see, enter. Then you can press ESC, and we set the wire, right? So we create it. And for example, we want to dimension, so we want to create a parameter on it. Great, so we can use the dimension tool and click on the circumferences. You can see the diameter is 1. We just set it. Drag and drop the dimension and click on it. Then if you go in the function button, you have the possibility to create variable. And you can see that L1 will be created. Right click and drag it to ESC from the tool, or just ESC. You can avoid to have this window later. Again, okay. So second thing, we want to dimension, for example, the position of the wire. So we can click again on the dimension tool, click on the center, and do the second click here. Sorry. Okay, so you can see the dimension will appear. You can position, drag and drop and position it, clicking when you are confident. And you can enter 10 because we want the position here. We want to position the wire here. So enter, and we can do the same. So we can create another variable. This variable cannot be used in SimLab 2024.1 in a simple way to perform DOE, but you can use these parameters with the script to perform multi-parametric analysis. So it's important start to know how to parameterize the geometry. Okay, so now we created two parameters, and yeah, we can have a look at them here because parameters are available in the parameters browser. So we was in the assembly browser where we can check the geometric entities, and in the parameters browser we have the parameters for sure. You can check it, and yeah, we have L1, L2 that are 10 millimeters and 1 millimeters. Great. Another way to check the variables is the variables here, the variable manager. If you click on it, you can see the two parameters, and you can add comments. For example, you can put for L1 conductor diameter, and for L2 coil radius, right? Sorry. Okay. Okay. Now we need to create the hair around to visualize the magnetic field on it. So the model can be solved also without the air around that we are going to create, but at the end you will see just the quantities on the wire, right? So for this reason, we are going to create the air around. And to create the air around, we can use again the circle by center and points tool, position the mouse at the in 0, 0. So click for the first time and then drag the second point. So you can drag and click on x-axis to create the circle. And again, the diameter, the possibility to enter the diameter is available. So we can type 35, right? And press enter. Okay. And ask to ask from the tool. But since we have an axisymmetric geometry, so what we need to do is to cut this circle to keep just half of it. So a new tool line can be selected. We can position the first point here and the second one at the opposite side. Okay, the length is 35 and is right because we have is the diameter of the circle. So we can press ask, and then we want to delete this part. How to do it? We have the trim tool, select the trim tool. Here, each time that you select one tool, you can see a tip here. So select or drag the mouse through a sketch entities to delete it. And you can enlarge the view. You have also some help dedicated to each tool. But you will see that SimLab, the Sketcher and SimLab in general is very easy to use. So to delete this part, we can just click on this line with the trim tool and the geometry is ready. So let me just read some question. Okay, so how did you replace the 1 and 10 millimeter with L1 and L2? Okay, let me show you quickly through the slide. You have so once you create, as you can see, for example, here, once you create the circle, the window will appear with the diameter of the circle you created. You can click on the function button and then create variable. If you click on create variable, in automatic way, a new variable will be created with the value you have in the window here. Okay, so then you can modify it for sure if you want, so it's available. But yeah, to create it, you have just to click on the function button and create variable. And the same is here. So we use the dimension tool. We select the first point, the second point here. We set 10 as distance, and then we select the function button and the create variable, and the L2 variable will be created. I hope this helps you and I hope this replied at your question. Okay, so the geometry is ready. As you can see, it's very easy to use SimLab. So we can, for example, fit the view if we are lost in some way. We can enlarge the view in a manual way if you want, and we can see the sketcher, 2 parameters, and in the assembly browser we have the sketch one, okay, as entity, sorry. Okay, so do you have some question about the view toolbar? This is very helpful. So you can find the possibility to use the different views, predefined views. So clicking just on the first icon, so you can use them. Then we have the possibility to capture the view. The fit tool, you can just press F, is very useful. Then we have the zoom. For example, we want to use the zoom, we can just click on it. Oop, this one. And yeah, and you can come back with F or just fit the view. We have the possibility to change the visibility to the entities and the cutting plane, but I think these tools could be useful later. And apart from that, yes, we can ask from the sketcher. As you can see, the background is the one of the sketcher, so we can press ask. Okay, and we can click on it and recreate. Click on edit. I don't know why this is disappeared. It doesn't matter. I can recreate it in case. Okay. So ask redisplay body. Okay, so I can, in case, create a new sketch. So sorry, we edit. Let me quickly recreate the sketch. Fit to the view. Okay. And second thing is, okay, dimension. We can create a parameter. Yeah, I want to have this parameter, so it's fine. It's already created. And sorry, dimension again. We want to have 10, and we can enter the parameter. Okay, so last step is to recreate the hair around and to cut it. And trim. Okay, this is the process we did, right? Great. So the first step is to realize the sketch once it is created. And to realize the sketch, we have to click to do the right click on the sketch and realize as multiple sheet bodies, all faces. Okay, and you can see that the two faces are available here. The name depends on the name of the sketcher. So we can press ask 2 times to help from the sketcher, and we can also make it invisible because the sketcher is an entity. Okay, so the geometry was done. Here we can rename the entities and change the color. For example, we want to have the orange for the wire, and we want to rename it as wire, or we want to rename the other body as a round or air, as you prefer. Okay, so before start the meshing process, I want to, since 1 hour is passed, so I leave you 10 minutes for the break. So see you in 10 minutes. And please, if you have some question, don't hesitate to put them in the chat.